Okay, so we're still on the consumer theory, how consumers make decisions with a limited budget, prices of goods and services, and our preferences. Those are some of the factors. That's how that affect the choices we make when buying goods or services. So we said important terms to remember are utility. Utility is the satisfaction we get whenever we purchase a good or a service. So today we're going to look at the budget constraint line and the indifference curves and how they interrelate. Okay. So the budget constraint line basically is an equation showing the price of the goods and services, your income. Okay. So let me just write it here. Budget constraint. It's in this format. Y equals P x multiplied by x plus P y multiplied by y. Okay. Y represents your income. And as it says, a budget constraint, it means you are constrained by your income. Okay. Your income has a limit. Okay. Px, this is the price of good X. X, this is the quantity of good X. Let me even put it like this. Qx. Okay, at least that way you can remember it's the quantity. Okay. Py is the price of good Y. Qy is the quantity of good Y. All right. Now, in other books and textbooks, you find px times x plus py times y, as I wrote it earlier on. But this is the format of the budget constraint equation. And when we graph it, this is how it's going to look. We have good y on our y-axis and good x on our x-axis. Right? So the budget line, you can say, it's just a straight line like this. Okay. Here, this is our x-intercept. Here, we have our y-intercept. Now I'll explain what both mean. And the slope of the budget constraint line is negative px over py. Okay, so I'll explain all those terms. So first, let me make an actual budget constraint equation, and then we'll get the x and the y-intercept, explain what they mean. We'll get the slope and explain also what it means. Okay, so for example, if you have a good, let's say the price of good x, px, is 2 kwacha. Py is 4 kwacha. Okay, these are the prices of the goods. Now let's put them in the, and let's say the income you have, income. So let's say you have a 100 kwacha income. Okay, so basically, you can't go beyond 100 kwacha. 100 kwacha is your limit. You can only spend 100 kwacha and below. All right. So with this information here, we can form a budget constraint equation. Where there is y, substitute it with 100 equals. Where there's px, substitute it with 2. So here we have 2 qx plus. Where there is py, substitute it with 4 qy. All right. This is our budget constraint equation. All right. So when we graph this, you're going to have a downward sloping line like this. Okay, so now I want us to interpret what the intercepts mean and what the slope means. Okay. So the x-intercept, it means you're only buying good x. Okay. So when you say x-intercept, it just means you're only buying good x. All right. So basically, what we're saying is if you're only buying good x, then it means you're buying 0 of good y. Okay. So if we want to find how much of good x can we buy if we don't buy any of good y? Okay. One way to find the intercept, okay, remember this formula, is your income over the price of the good. Okay. So basically one say, okay, with our 100 kwacha, how many of good x can we buy? Specifically, only good x, no good y. All right. So M is 100 kwacha. The price of good x is 2 units, 2 kwacha. 100 divided by 2. So we can buy 50 units of good X only. Okay, if we spend all our money on good X, we can only buy 50 units of good X. That's what our X intercept is meaning, all right? Where we're only buying good X. Another way we can get your X intercept, because remember here, you're only buying good X, you're not buying any of good Y. So you can also equate qy to 0. Okay. If you equate qy to 0, here, 4 times 0, that becomes 0 here. You just remain with 100 equals 2qx. You want to find the value of qx, divide both sides by 2, and you find that 100 divided by 2, that is 50 units. Okay. So that's what the x-intercept means. Any questions before we go to the y-intercept and then the slope? Okay, the y-intercept, basically we're asking ourselves, if we only buy good y, okay, if we only buy good y, how many units can we buy of it? So the y-intercept is just your income divided the price by the price of good y. Okay, so your income is 100 kwacha, the price of good y is 4 kwacha. So you can only buy 25 units of good y. If you spend all your income on good Y, you can only buy 20 units, 25 units of good Y. Okay, so that's what the intercepts tell you. The y-intercept, if you're only buying good y with all of your money. The x-intercept, if you're only buying good x with all of your money. Now we can go to the slope. Okay, this is the formula for the slope, negative px over py. All right, so in this, if we use the information from this question here, px is 2. So here, this negative sign, that's why we have a downward sloping curve. Okay, and this slope basically is telling us how many units of which a certain good you need to give up to get another good, basically. Okay, basically how many units of x you need to give up to get y, or how many units of y you need to give up to get x. Okay, so our slope here is the same as negative 2 over 4, which can be substituted to negative 1 over 2. So this is how we can interpret the slope. Okay, you can say, let me just put it here. So on top, remember, you're referring to good x. At the bottom, you're referring to good y. All right. So here, what this slope is telling us is to get 2 units of y, you need to give up 1 unit of x. All right. To get 2 units of y, you need to give up 1 unit of x. Okay. We can simplify it further. Negative half is the same as negative 0.5. Okay, here just ignore the negative sign. Okay. So here, when we simplify this fraction into this decimal, it's basically telling us to get 1 unit of y, you need to give up 0.5 units of x. Give up 0.5 units of x. Okay, colleagues? Most books, that's how they interpret it. The denominator is what you're getting, and the numerator is what you're giving up. Okay? So here, this 1 over 2, to get 2 units of y, you have to give up 1 unit of x. So if you want to find out, okay, what about if I want to get 1 unit of y? How many x should I give up? That's how we divided and got this 0.5 units. Okay. It can also be interpreted the other way around, okay? But most books interpret it like this. Okay, but the other way around, you can think of it like this. To get 1 unit of x, you need to give up 2 units of y. Okay, that's another way you can think of that. Okay. It just depends which one are you going to refer as the one that's being given up. Is it the numerator or the denominator? So the general approach that you're going to see with books is the denominator is what you're getting and the numerator is what you're giving up. Okay, so here to get 2 units of y, you have to give up 1 unit of x. Okay, you can even put it in a ratio format. 2 units of y, get 2 units of y, you have to give up 1 unit of x. What about to get 1 unit of y? You can solve and say, okay, well, how much you cross multiply and you see you still get 0.5. Yes, any questions? Right, so that's how you interpret the slope. The denominator is what you're getting, the numerator is what you're giving up. Now we can go to indifference curves. Okay. Colleagues, what does it mean to be indifferent? When someone says you are acting indifferent, let's say, for example, there is something has happened, and then they say, but how come you are acting indifferent to what has happened? What does to be indifferent mean? Okay, basically it means not to be affected. Okay, in simple terms, not to be affected. So the indifference curve, what it's showing, the combination of goods, okay, combinations of x and good x and good y, that we can get maintaining the same level of satisfaction. Okay, so if we look at this indifference curve here, if we look at point A here, okay, if we say point A is 10 and point B, let's say this is 5. So this is 2 and this is 4. Okay, so at point A, you can have 10 units of good y and add 2 units of good x. So 2 units of good x, 10 units of good y. Okay. And at point B, you can have 4 units of good x and 5 units of good y. So on this indifference curve, our satisfaction is the same. Okay, whether you have 2 units of good x and 10 units of good y, or 4 units of good x and 5 units of good y, your satisfaction is still going to be the same. Okay, that's what the indifference curve is telling you. Okay, any point, even here, let's say if we have point C here, let's say here point C, this is 4. So here it's 6. So here point 6, you can have 6 units of good X and 4 units of good Y. But your satisfaction is going to stay the same. Okay. So any point in so in the indifference curve, it's just showing you the different combinations of the goods. Okay, while you're maintaining the same utility, the same satisfaction. Okay. Yes. And then also, is that a question? Okay. So for indifference curves, usually the first you'll be given a function. Usually the function you see it something like this. Okay. Other times you see the function with exponents like this. Okay. Yes. This is how the functions of indifference curves are usually represented. And the slope of the indifference curve, which is given as the marginal utility of good X over the marginal utility over good Y. Okay. Oh, not over, not negative good Y. Yes. Right. Marginal utility, this is the additional satisfaction you get when you consume an extra good. Okay. That is what marginal utility is. So the slope of the indifference curve, this is how it is represented. And this slope is called the marginal rate of substitution. Okay, the marginal rate of substitution. Okay, how many? It's basically telling us almost the same thing like this slope for the budget line. How many you have to? How many goods of X you need to give up to get Y basic? Same thing. How many units of X you need to give up to get Y? Because remember, as I said, with the slope, we said what we're getting is in the denominator, what we're giving up is in the numerator. So the marginal rate of substitution is just telling you how many units of X you need to give up to get Y. Okay, that's the slope of the indifference curve. So according to the consumer theory, right, for you to maximize your satisfaction with the optimal band with the budget constraint, okay, yeah, we're going to see the slope of the budget constraint line px negative px over py equals negative mu x over mu y. Okay, this equation is going to give us the best bundle choice where we're going to have the best satisfaction with our budget constraint. Okay, and basically this can be represented like this. It's basically where the, the indifference curve is tangent to the budget constraint line. Okay. In mathematics, when we say tangent, it just means the indifference curve and this and the budget constraint line have the same slope. Okay, they have the same slope. So where the indifference curve and the budget constraint line meet this this choice or this bundle of good X and Y will give you the best satisfaction, okay, um, with your limited budget, okay, and that's why it is represented like this. Any questions? Good evening. It's being recorded, yes. Okay, so now we're going to illustrate this same law here. Okay, I'm going to give an example. Just hold on, colleagues. Let me get a light. Power has just gone here. Let's get a candle. Okay, yeah, so I'm going to illustrate an example where we're going to see how we can determine the optimal bundle. Okay, whenever you hear the optimal bundle, this is the bundle that will give you the most satisfaction, okay, with your limited budget. Okay, so in this example, we're going to have a scenario where we want to find out what is the optimal bundle for, for this certain consumer. Okay, so let's say, for example, you have a utility function. You are given a utility function here. X to the power 0.5, y to the power 0.5. And let's see, let's use the same information here. The price of good X is still maintained as 2 kwacha. The price of good Y is 4 kwacha. And your income is 100 kwacha. Now I want to find out what combination of good X and good Y can we get so that we maximize our utility. Yeah? When you hear these words, maximize utility or get the optimal bundle, These are the type of questions we're dealing. So I remember in your assignment you had a similar question. You were dealing with Langrendian functions. So I'm going to show you with first when we use the marginal rate of substitution way of solving this question, and then I'll also show you with the Langrendian functions. Right. First, let us start with the marginal rate of substitution way. Basically, the marginal rate of substitution way, we're going to use this here to find the optimal bundle of goods. So first things first, with this type of questions, you make the budget constraint equation. Right? We already made. So our budget constraint equation is 100. This is our y equals. Let me put the format so that everyone sees where everything's come from. Here's the format again of the budget constraint. Y equals px times qx plus py times qy. Yes, so price of good x, that is 2 qx plus price of good y, 4 qy. Okay, so using this equation here, all right, we need to first get our marginal utility for good x. We also need to get our marginal utility for good y. Okay, so the marginal utility, these marginal utilities, we're going to get them from this utility function here. Okay, so the marginal utility of good x, and getting the partial derivative of the utility function with respect to good x. Okay, so basically when you're deriving this function, the variable that you're focusing on is x. Okay, so remember from calculus differentiation, if we derive this with respect to x, so here we're going to say this 0.5 multiplied by the coefficient. 0.5 times 1, you get 0.5. Then you always subtract a 1 from the exponent. So 0.5 minus 1, that is negative 0.5. Okay, so you have 0.5x to the power negative 0.5. Then this y, you're not going to derive it. It will stay the same. Okay, y to the power 0.5. Any questions before I move further? Okay, so let me just use x and y to represent qx and qy, because these equations, there'll be some parts where we need to substitute. So yes, there'll be a part where you need to substitute, and then you find qx. You're using qx and qy, might get confused. Okay, so just remember this big letter x is the qx. This big letter y is the qy. Okay, because there'll be some substitution going on, so that's why I've replaced them. Then we get our marginal utility of y. The marginal utility of good y is the partial derivative of our utility function with respect to y. Meaning, in our utility function, we're only going to concentrate on the variable we're concentrating on is y. Okay, so let me just put it like this. Yes. So we derive. So since we're deriving y, you just say this 0.5 multiplied by the coefficient here, you get 0.5. 0.5 times 1, 0.5. X stays unaffected, so it will be x to the power 0.5. Then remember you subtract a 1 from the exponent, so this 0.5, which is the power of y, when you subtract it by 1, it becomes negative 0.5. So we have y to the power negative 0.5. All right. Any questions? So we found the marginal utility of x and the marginal utility of y. Okay, so now we equate these expressions here. Okay. Now, since this is negative and this is also negative, so the negatives, you can cross them out. Okay. So here we have px equals py equals mux, marginal utility of x, over muy, marginal utility of y. Okay. Remember, marginal utility of x over marginal utility of y, that's just your marginal rate of substitution. Okay. So here, first thing that we need to do is we need to simplify this marginal rate of substitution here. Okay. Our px, remember, the price of good x is 2, price of good y is 4, equals here, marginal utility of x, that is 0.5 x to the power negative 0.5 y to the power 0.5 over y, which is 0.5 muy, x to the power 0.5 y to the power negative 0.5. Okay. As I said, we need to simplify. Now, there are many ways of we can do this. First thing, we can cross out these 0.5s here. All right. If you remember, according to the law of indices, whenever you are dividing powers, the same as whenever you're dividing two terms with powers, it's the same as you are subtracting the powers. Okay, so this x here, it's like x to the power negative 0.5 minus 0.5. Okay, so basically this 0.5, this negative 0.5 in the numerator, we are subtracting it from this 0.5 in the denominator. That's what's happening there. Okay, another way you can do it is you can bring this, since this is a negative power, you can bring it to the denominator. Okay, and then you have to add there. Okay, so many ways of doing this. For y, it is 0.5 minus negative 0.5 Okay, here this 2 over 4 can be simplified as 1 over 2. Okay, so we solve 1 over 2 equals, so negative 0.5 minus 0.5, that's negative 1. So we have x to the power negative 1. 0.5 minus negative 0.5, that is 1. So x to the power negative 1, y to the power 1. Then we apply indices again. 1 over 2 equals, remember, whenever you have a negative power, you get the reciprocal. Okay, so basically, this x to the power negative 1 comes at the bottom and becomes x to the power 1. Are we okay with this, colleagues? Any questions? So we can cross multiply. X times 1, you get x. Y times 2, 2y. Okay, so x equals 2y. So this x equals 2y, we're going to substitute it into the budget constraint equation. Okay, that's why I replaced the qx and the qy. Okay, so that to avoid confusion there. So this x equals 2y, we substitute it back to the budget constraint equation. Because remember, here we want to find out how many units of good x and good y should this consumer get so that their utility is maximized, their satisfaction is maximized. So our budget constraint is 100 equals 2x plus 4y. We substitute x with 2y. So here at 2, then we substitute x with 2y here. Plus 4y. Okay, so 100 equals 2 times 2y, that is 4y, plus 4y. Okay, so 4y plus 4y, that is 8y. 100 divided by 8. What is 100 divided by 8? Are we there, colleagues? 100 divided by 8? 12.5. Okay. Then, since y equals 12.5, we can now get the value of x. So where there's, go back to our original equation, 100 equals 2x plus 4. So where there's y, we substitute with 12.5. 4, 12.5. 12.5 times 4. That is 50. 2x plus 50. So we take 50 over the equal sign. 100 minus 50. Get our 2x here. 100 minus 50, that is 50. Get the value of x. 50 divided by 2, that is 25. 25 units. So colleagues, for this person to get the most optimal satisfaction, they have to get 12.5 units of y and 25 units of good x. Okay. That way, when they buy that bundle, they will be very